Hey everyone, this is Andrew from SciChart. In this video we're going to be talking about SciChart WPF V6 Accelerated Edition, which has up to 100 times or 10,000% faster WPF charts. In the latest release of SciChart, we have completely rewritten our rendering engine, which previously used DirectX, but we've used it in a completely new and different way in order to achieve record-breaking performance. So we've brought you a solution which is now, we believe, the world's fastest WPF chart by a long shot, and it has lower CPU usage and memory usage than all known competitors. In order to test this, we had to build a performance test app. So on the website, we have some graphs showing you how much faster it is. But to prove this, we've built a performance test suite. We haven't released the source code for the performance test suite because in the past, one of our competitors actually took a performance test suite that we created and used it to optimize their own code. But we're more than happy to show you a demonstration of it nonetheless. The performance test suite is included in our own internal source code. We don't publish it, and to do testing I have today built in release mode and I have run the application. So this is what the performance test suite looks like. It's got a number of options which allow us to set the buffer size for various things and to enable memory limits, C++ resamplers, and acceleration mode because we're using some techniques under the hood. And with the default, then what we can do is do tests of our old DirectX charts versus the new Visual Xccelerator charts. The tests are broken down into different categories. For instance, in line series tests, then we have line series tests here, we initialize 1000 series with 1000 points and with a stroke thickness of 1. So this is the old DirectX 5 engine and this is the new Visual Xccelerator engine. And if I run these tests, you can see what they do. You can ignore the licensing warnings, that's just on my local PC. 1000 series are created here and then the chart is zoomed out and we measure the FPS and that is stored down here in the table below. So once the tests are finished, I'll scroll over to the right and you'll see that the DirectX version managed 18 FPS and the Visual Xccelerator version managed 52. Now that's for a simple test of 1000 series by 1000 points, but then another case might be one series with 10 million points of unsorted data. As some of you know, unsorted data requires that we draw everything. We cannot really accurately resample or compress time series that are unsorted, certainly not lossless. So we have to draw everything. So in this case, the old rendering engine, this is using Direct 3D11 render surface, which was available in version 5 of SciChart, manages 1.89 FPS. But the Visual Xccelerator engine manages 24 FPS. So we're about 12 times faster now for this particular case. Also, it gets worse. So if you have features such as palette provider or dashed lines or lines with not numbers, then these special cases are now all handled on the GPU. So in the previous version of SciChart, what we had to do was to do the paletting. We had to basically stop and restart drawing, which is terribly bad for DirectX. So in the new version, we are now beating all the performance by doing all of this work on the GPU. So performance comparison here for using the palette provider is 0.84 up to 33 FPS. So that's over 30 or 40 times roughly increase. Other series types have been accelerated too, not just line series. So we can take a look at, say, band series, and we'll choose a similar test. So we have 1000 series with 1000 points, and let's run this one. So this is the old Direct 3D11 render surface. As you can see, it's extremely slow, and that's managed 0.57 FPS. Whereas the new Visual Xccelerator engine, we are implementing and drawing everything on the GPU. And this has managed 44 FPS. So in this case, we're about 80 or even 90 times faster for band series. The same would go for mountain series. So let's say that we take mountain series and we compare 1000 by 1000 points. I mean, it'd be even worse with the palette provider. I'm curious to just try this out. So let's run it. So the old Direct 3D 11 render surface. Not sure if it's even going to draw. Oh, it did it, but it drew once and we got 0.19 FPS. This is the new Visual Xccelerator render surface, and this is drawing a lot more smoothly. So here we are, 20 FPS. Now that's a very difficult case, 1000 mountain series with 1000 points and a palette provider. But in this case, it looks like we're around about 100 times faster. So pretty much everything has been accelerated in SciChart WPF v6. And we could go through some more of these tests. So for example, append FIFO single line. So let's try this one. So let's try 100 million points in the old one and 100 million points in the new one. And in this case, what we're using is our lossless time series compression algorithm in order to draw charts. So this is Direct 3D 11 render surface that was available in version 5. And it is drawing, but it's a little bit slow on the screen. So we got 7 FPS here. And this is SciChart WPF v6 with Visual Xccelerator. And this is looking a lot smoother when we run the application. So this one, I'm predicting close to 60. There we go. So that's kind of to be expected. Now I'm going to uncheck this one and just go to 1 billion points. I'm not going to run 1 billion points on the old one. I think it would be far too slow. Actually, do you know what? Let's do it. Let's see what happens. So we'll run 1 billion points on Direct 3D 11 render surface that was available in version 5. And you can see the hourglass is showing there. It's taking a long time to load, but it has loaded nonetheless. So SciChart WPF v5, for this number of points, it would be useful for, say, a static image, but not a real-time one. And now Visual Xccelerator is loading the same data. We still have hourglass because it does take a long time to generate that many points, but we are drawing these points now, and it appears to be updating a lot more quickly than 0.8 FPS. There's some aliasing occurring there, but you know, that can be improved with settings. So here we go. This is a billion points. So it looks like 2 billion points in the point count here. Maybe there's an inaccuracy in our test, but you get the idea. What was impossible in version 5 is now possible. Even series types such as candlestick. So if we were to take candlestick, and a very unrealistic test is that we're going to test out 1000 series. Here we go. Let's do all 4 of them. So these are version 5 and these are version 6. So let's run these and see how it performs. So this is Direct 3D 11 render surface. Version 5, and that's a candlestick or an open, high, low, close chart. And this is also version 5. And version 6 is a lot smoother, as you can see. And also version 6. So in this case, we're running around about sort of 20 times faster for candlestick, open, high, low, close, and almost 50 times faster here for open, high, low, close. So SciChart WPF version 6. So there you have it, folks. It really is up to 100 times faster. Almost everything has been hardware accelerated. We're sending all the data to the GPU. There's no losses in our chart. Some people have said that SciChart loses data by decimating. That's absolutely not true. We have a lossless time series compression algorithm in our chart, so you do not lose the visual appearance of your charts. SciChart WPF v6 is up to 10,000% faster than v5, and it performs well on a wide variety of hardware. Also, in addition to this, we've reduced the CPU usage and reduced the memory usage of SciChart WPF. I hope that gives you an introduction into SciChart SDK v6. If you have any questions, leave them in the comments or contact us at scichart.com.